All right, Algebra 2, welcome back, guys. Hope you're doing good. Stay motivated, okay? Watch these videos. They are the key to doing well in this class. Okay, let's jump into it. So we are in section 6. That is on page 134. Be there right now. All right, textbooks, open them up. Page 134. It is transforming linear functions. Okay, now the two charts, that's the first thing that it says here in your notes. Copy the two charts, give you the titles there, translations and reflections, page 134, and copy the other chart, stretches and compressions, on page 135. I can promise you these charts will be used again. So take the time now to write them down, understand them, and memorize them. That's a new idea, right? Because this will come back again and again and again in this class, all right? Throughout the whole year, they will take a concept and then they'll make you transform the graphs. And then they'll make a harder concept and they'll make you transform the graphs, all right? So learn it now, make your life better later on. Okay, now as I wrote right there again, the charts are so important. Use this time wisely. All right, now the next thing is we will very soon be coming up to the point where those graphing calculators really need to be with you. Okay, so I'm giving you some very heads up notice now. I know I already put this up on your Google Classroom, and I know we've already talked about it in Zooms. So this right here is kind of your last notice. If you don't have it, you really need to get it, because section 7, we use it quite a bit. And then we're just going to keep using it throughout the whole year. I'm going to teach you what to do and how to use it. But if you don't have it, it doesn't matter. It's not going to make sense to you, and the homeworks are going to be quite difficult. Okay. Now, let's jump into it. Okay. So what I'm trying to do here is take a concept and just minimize it down. Let's just understand the minimum here that's going to get you to really getting your problems correct. Okay. So a horizontal shift is in the parentheses. Those are parenthesis markers. That's what I mean by that. Okay, so a horizontal shift is when you are inside the parentheses, and then you will notice minus signs, like x minus, and then they'll put a number. When they say minus, that actually means go to the right. And when they say plus, then that means go to the left. Okay, I know, as I said, trust me, it seems backwards. It's not. All right, so remember that part. And then a vertical shift is when it's completely out of the parentheses. So out of the parentheses, then you'll see plus and then a number, or you'll see minus and then a number. Now, if it's out of the parentheses, then everything goes back to like being logical. A plus means go up. All right, and then a minus means go down. So that whole logic stays true. It's only for the horizontal shift that it gets weird and a little different. Okay, now a reflection over the y is making x a negative in the parentheses. So in the parentheses, you'll see negative x and then something. But if it's a reflection over the x, then you put the negative in front of the entire equation. Okay, and a lot of times that means that the entire equation is going to be in a parenthesis, but that negative sign is outside the parenthesis. Okay, and then let's move over to the horizontal stretch. All right, if you have a horizontal stretch, that is a fraction in front of x in the parentheses. A horizontal compression would be a whole number, meaning a number that is bigger than 1, and that is in front of x, but still inside the parentheses. Okay, now if you want a lot more examples, take a look at the textbook, because these example problems that we have right here will cover most all of these concepts. But again, more examples, take the time, it helps you in the long run. All right, and the last little piece we have here is a vertical stretch. That's a whole number in front of the entire equation. So again, that would be the whole equation is in parentheses, and outside of the parentheses, in front would be a whole number. That's going to be a vertical stretch. If you want a vertical compression, that's going to be a fraction that is in front of the entire equation. So think a number bigger than 0, but a number less than 1, a fraction. Okay, let's jump into our example problems here. All right, so the function f of x equals 3x plus 1. We want to translate this 2 units to the right. So let's do our quick refresher. Go up to the top here, right there. It's a horizontal shift because that's what left and right is. So we have a horizontal shift. And what direction do we want to go? We want to go to the right. But if you remember, it's a little bit backwards here. That means that in the parentheses, all right, follow me. In the parentheses, that means that we will have a minus sign if we want to go to the right. Okay, so there we go. We're going to translate it 2 units to the right, and we only want to affect the x. All right, so if you want to take a look in the textbook, we are looking at example 1, but it's going to help us to have that picture. Again, that whole chart is right on page 134. So now let's write what we should have here. We have a 3, but we don't want to include that 3 in the parentheses. We only want this to affect the x. Okay, we only want it to affect the x. And if we want to go to the right, that means we're going to have a minus 2 and then close the parentheses and then have the plus 1. Okay, so let's review. If you want to have a horizontal shift, which means translating it left and right, you will put the extra part inside parentheses only with the x. If you want to go right, put minus. If you want to go left, put plus. All right, this is our solution for number 1. Now let's move in to number 2. We have to use the table to make a function. So before anything can happen, we have to create what f of x really is. And how do we do that? The first thing you do is you take a look at what the x value is and ask yourself, how do I get to the y value? So the first one, we have a -1. We want to get to a +1. Well, if I just add 2, it works. And I know that may sound overly simple, but it does work. And now you need to check and see if it works for the second and the third numbers that they give you. So if we have 0 and we add 2 to 0, we get +2. So it works again. And it looks like it's going to work here. If we have 1 and we add 2, we get to a +3. So we just created our function x plus 2. Okay, second step, they want to take that function and reflect it across the x-axis. Let's do that quick review. Where in our notes does it say reflections? Right here. We want to reflect it over the x. So what do? We put a negative in front of the entire equation. So let's go. And that must mean I have to put the entire equation into parentheses and then put a negative sign in front, because that means the whole equation is now affected by that negative sign. And that is it. That would be us creating a function. Step 1, use the table. Step 2, then reflect it over the x. All right. Let's now take a look at example 3 here. So they give us a function 3x plus 2. Now we're doing a vertical compression by a factor of 1/4. Okay, let's go back into the notes. Where do we talk about vertical compression? We talk about it right here. Vertical compression is a fraction in front of the entire equation. Anytime you hear entire equation, think parentheses must be used somewhere. All right. Now, let's take that entire equation, 3x plus 2, and put the whole thing in parentheses. And then we will have a vertical compression by that 1/4 factor. That is it. It's as simple as that. You can see this is very conceptual. All right, there's not really much math, if any, occurring, but it's conceptual math. It's, do you get the concept, and do you know how and where to apply the concept? All right, guys, this is our last example problem, so here we go. The original function f of x simply equals x. They want us to write a brand new function, g of x. They want it to have a vertical compression by a factor of 1/2 and a horizontal shift 8 units to the left. All right, so this is kind of a little like a mini culmination here. Let's create a new function, g of x. All right, now a horizontal shift, that's our left and right. That means we have to take x and put it in parentheses. And if we go 8 units to the left, that means do the opposite and add 8 to x. Then the last piece here, they want a vertical compression by a factor of 1/2. And if you look back in your notes, a vertical compression means we have to take the whole equation, which, by the way, it's already in parentheses. So there's the equation, and multiply it by the factor given. In this case, the factor given is 1/2. That's it. You're looking at it right there. That is your solution. We took the original function, simply x. We shifted it left 8 times by putting x plus 8 in parentheses. And then outside those parentheses, putting a 1/2, which tells us a vertical compression by a factor of 1/2. There you go, guys. All right, watch it, re-watch it. You got to think to yourself, if a normal class period could be as short as these video lectures, you probably would like that a lot. So take the time in these video lectures to watch them, re-watch the parts that don't make sense, copy down your notes, and you will be just fine. All right, put in that time. All right, guys, we'll see you in the next one.